Hello, this is my 20th lecture for the session 2, and we shall discuss today a special type of capacitors. There are spherical capacitor and cylindrical capacitor. Now first of all we shall discuss about the spherical capacitor. Spherical capacitor. In a spherical capacitor, there are two concentric hollow spheres and a plate is provided and it crosses the outer sphere untouched, and this plate is connected to inner sphere. The radius of inner sphere is Ra and radius of outer sphere is Rb. Now we give some charge to the plate. This goes to the inner sphere and accumulates at its outer surface. No charge exists inside the sphere because it is hollow. And now, by the process of induction, minus Q charge is induced at inner surface of the larger sphere and plus Q charge is induced at the outer surface of large sphere or sphere B. Now, when we provide earthing to the outer sphere, the positive Q charge of outer part of the sphere goes to the earth. So in this manner, now we have plus Q charge on outer surface of the smaller sphere and minus Q charge at the inner surface of the outer sphere. So in this manner, this is called the spherical capacitor. Again, I am telling you, there are two concentric hollow spheres are adjusted and a plate is provided to the capacitor also, which is connected to the inner sphere and crosses the outer sphere untouched. And now we provide the plus Q charge to the inner sphere by the process of induction. Plus minus Q and plus Q charges are induced at inner and outer surfaces of the outer sphere. Now on providing earthing to the outer sphere, the plus Q charge of its outer surface goes to the earth, and in this manner we obtain a spherical capacitor. Now we shall consider that the potential at the first sphere KQ upon RA and VB is equal to KQ upon RB. This is with negative sign because this potential is developed with minus Q charge. So net potential V is equal to VA plus VB. Means KQ upon RA plus minus KQ upon RB, and V is equal to KQ RB is considered as a LCM. So RB minus RA will be the value, and by the process of by the definition of capacitance, C is equal to Q by V. Now put the value Q upon KQ RB minus RA into RA RB. Q and Q cancelled out. and value of A is 1 upon 4 pi epsilon naught. So the capacitance of the capacitor will be is equal to 4 pi epsilon naught RA RB upon RB minus RA. This is the expression for the spherical capacitor, and one numerical in additional exercise is given for the basis of on the basis of spherical capacitor. And in order to increase the capacitance of spherical capacitor, the radii of the hollow spheres must be greater, and the difference between the radii of the spheres should be smaller. Means for better capacitance, RA and RB should be greater. RA, RB should be greater, and then difference RB minus RA should be smaller. So this is the condition for spherical capacitor, and in this capacitor, for better capacitance, RA and RB should be greater, and the separation RB minus RA should be smaller. So this is the spherical capacitor, the first type of spherical capacitor. Now we shall discuss about the cylindrical capacitor. Okay, now we shall discuss about the cylindrical capacitor. Cylindrical capacitor. For cylindrical capacitor, two coaxial cylinders, hollow cylinders, are given to us. Inner cylinder may be solid or hollow. It will not affect the capacitance. So two coaxial cylinders are provided us, and the inner cylinder is connected to a plate, metal plate, and this is the axis which is common of inner and outer cylinders. Now when we give some charge to the inner cylinder, it accumulates at the outer surface of the inner cylinder, like it is plus Q. Then by the process of induction, minus Q and plus Q charges are induced at inner and outer surfaces of the outer sphere, outer cylinder, and this is plus Q, this is plus Q. When we provide it earthing, the whole charge goes to the earth by the process of through the earthing, and whole charge goes to the earth. So only plus Q charge is induced at the inner cylinder, and length of the cylinder is L, and the inner radius is RA, and outer radius is RB. inner radius is RA and outer radius is RB. And L is the length of the cylinder and Q is the charge given to the inner cylinder. Now we know that the electric field intensity, again I am repeating the construction and working of capacitor. There are two coaxial cylinders of length L and radii RA and RB. The radius of inner cylinder is RA and radius of outer cylinder is RB. And a metal plate is connected to the inner cylinder. When a plus Q charge is provided to the metal plate, it goes to the inner cylinder and accumulates at the outer surface of the inner cylinder. And now by the process of induction, minus Q and plus Q charges are induced at the outer cylinder, and when a earthing is provided to the cylinder, the positive charge of outer surface of outer cylinder goes to the earth and minus Q charge remains at the inner surface of the cylinder. Now we know that the electric field intensity E is equal to 2K lambda upon R, and here R is greater than RA and less than RB. R is the any distance from the common axis and width between the cylinders. So E is equal to 2K lambda upon R and E is equal to 2K Q upon R into L. The linear charge density is equal to charge per unit length. Lambda is equal to Q by L. So E is equal to 2K Q upon R L. This is the electric field intensity between the cylinders. Now we know that V is equal to integral E dr, because we know that E is equal to dV upon dr and radii are RA to RB. RA to RB. These are the radii, and V is equal to integral RA to RB 2K Q upon L into R dr. We know that 2KQ upon L is a common, and integral RA to RB 1 upon R dr. So V is equal to 2KQ upon L, and the integration of 1 upon R dr is log R base A, RA to RB. Now V is equal to 2KQ upon L into, we put upper limit RB minus lower limit RA. And we know that V is equal to 2KQ upon L into log base E RB upon RA. Now, by the definition of capacitance, C is equal to Q by V, Q upon 2KQ log dash E RB upon RA into L. Q and Q cancelled out, and the value of C is equal to L upon 2K log RB upon RA. This is the value of C, capacitance. If we want to put the value of K, and we know that K is equal to, we know that K is equal to 1 upon 4 pi epsilon naught. So the value of C, L into 4 pi epsilon naught upon 2 log base E RB upon RA. 2 and 2 cancel out. So capacitance will be 2 pi epsilon naught L upon log base E RB upon RA. This is the expression for the cylindrical capacitance, for the cylindrical capacitor. C is equal to 2 pi epsilon naught L upon log base E RB upon RA. This is the expression for the capacitor. Again, I am explaining the cylindrical, between the RB and RA, we consider a certain distance R at which the electric field intensity E is equal to 2K lambda upon R, where lambda is the linear charge density, Q by L. So E is equal to 2KQ upon R into L. Now we know that E is equal to dV upon dr with magnitude. Actual relation is E is equal to minus dV upon dr, but here we consider only the magnitude. So E is equal to dV upon dr. So V is equal to integral E dr. Now we put the value of E, 2KQ upon L into R. Here we put lambda is equal to Q by L. So Q by L is there. Now V is equal to 2KQ upon L is a constant and can be taken out from the integration, and integral RA to RB 1 upon R dr 2KQ upon L. We know that the integration of 1 upon R dr is equal to log R. Now we put the value of log base ER, and now we put upper limit log base ERB minus log base ERA, and we know that the formula log A minus log B is equal to log A upon B. So in this manner, log RB upon RA, this is RA. And now by the definition of capacitance, we know that C is equal to Q by V. So C is equal to Q by V. The value of V is Q upon 2KQ log RB upon RA into L. Q and Q cancelled out. And C is equal to L upon 2K log RB upon RA. Now we put the value of K. K is equal to 1 upon 4 pi epsilon naught. So C is equal to L into 4 pi epsilon naught upon 2 log base E RB upon RA. 2 is divides the 4 by 2. So C is equal to 2 pi epsilon naught L upon log base E RB upon RA. This is the expression for the capacitance of cylindrical capacitor, and also we know that the numerical in additional exercise is given on the basis of this. So you see the derivation, special type of capacitors, and this is the derivation.